Welcome everyone to my session about performance and execution plan improvements in SQL Server 2025. The name is a bit of a misnomer, abstract as well. When I submitted it, I was still under the impression that I would be able to cover everything. There is more in SQL Server 2025 than I can fit in a single hour. So perhaps we should call it some performance and execution plan improvements in SQL Server 2025. Anyway, let's talk and let's start with saying hello. My name is Hugo Kornelis. I make SQL Server fast.com, which is a website that I created many years ago, still working on it, still building it, to provide the documentation that, frankly, Microsoft fails a bit at. So you will find the execution plan reference there, very complete description, documentation of everything in execution plans. If you ever encounter anything in an execution plan that you don't understand, I hope that my description will provide you with a clue. Now, as a reference, this is not a good place to start learning. So I also created the execution plan video training, currently at over 20 hours of content, still working on more, some of it available for free, some of it sold for a very moderate price. But for me, at least, as a Dutch person, any price is too high. I always want a discount. So from now until the end of February, all of you can use the discount attend. I'm funny like that, to get a 10% discount on all videos that I sell. Or if you want to attend one of my pre-cons, for instance, next week in Vienna or in March in Brouwersdam or in the Netherlands, then you will get a 20% discount code that is not time-bombed. So pick your poison. I also have a YouTube channel where I create what I call quick and dirty videos, just quickly slapped together to quickly put something out there. And you can watch them if you want to. And I have a lot of other content. I have a blog there, I have articles there. The most important thing for you right now is if you go to SQLServerFast.com and you in the menu you click other than presentations, then presentation resources, you will find a list of all my conference sessions. You can click any of them. For instance, this one, you can download an archive with the slide deck and the demo code. The one that's there right now is slightly outdated. I made some modifications the last days when I prepared for this talk. If I don't forget, I will upload a new version, but most of it is unchanged. It's small modifications. So if you want to review the slides later or play with the demos, you can. It's all there for you. I also try to earn some money every now and then by doing consulting or doing paid in-house training. Contact me if you're interested, but really you don't care about who I am and what I do. The only thing you really should care about is how to reach me. If you have questions during this session, type them in chat. I have Ben here with me. He will interrupt me and ask your questions to me. But if you have questions later, you can always reach out to me. Use email, use Blue Sky, drop me a line, let me know what your question is, and I will get back to you. So let's talk about SQL Server 2025. Officially released November 18 last year, but the first CTP was already available in May 2025, and before that there were private beta versions. The demo version I'm going to use now is the RTM version. There was not a cumulative update, but what's it called? A patch thingy, there's a name for it. Not the COD, other train. Yeah. Anyway, that was released this week. I didn't install it. So this should be the RTM version. There are no significant changes. I think there's 1 or 2 bug fixes in there, nothing else. Anyway, there's a lot of new stuff in SQL Server 2025, and a lot of that has impact on execution plans. A lot of that has impact on performance. I am not going to talk about all of it. My plan when I created this session was to talk about optional parameter plan optimization, optimized Halloween protection, and optimized logging. All the O's, pure coincidence. Optimized Halloween protection didn't make the cut. There was a problem discovered in optimized Halloween protection during one of the CTPs. The feature has been disabled. It has not been re-enabled yet. I don't know whether Microsoft plans to. I left the slides and the demo code in because you might be interested, but it doesn't work. And I'm going to skip that part. Optimized logging is basically the afterthought of this presentation, depending on time. Optional parameter plan optimization and everything related to it will be the biggest part of this hour. So let's talk about optional parameter plan optimization, and let's first talk about what problem we are looking at and how that problem is caused. So before I come to the problem, I need to explain two features in SQL Server that have been there like forever. One of them is parameter sniffing, and parameter sniffing has a bad name, but parameter sniffing is actually a good feature. What people often mean when they say parameter sniffing is bad is that it can backfire, and I call that bad parameter sniffing. But let's first talk about the feature, the very much intended feature of parameter sniffing. So let's say we have a query like the one on your screen. We're querying something and there is a where clause there that gives us a cutoff date. Fairly standard. I bet you all have reports like that in your production workloads where someone gives a cutoff date and then you can get the report for the week to date or the month to date or the year to date or the last 5 years, whatever you are interested in at that time. Now, when SQL Server tries to come up with an execution plan for a query like this, it needs to predict how many rows it will encounter based on where order date is larger than the cutoff date. And this is a challenge because often the cutoff date is not known to the optimizer. And in a case like that where you have no clue what the cutoff date will be, if I asked you what percentage of rows will come back, you have no clue because the cutoff date might be yesterday or it might be somewhere in 2010. And you have no idea. It can be anything from just 5 rows to the entire table. The optimizer still needs a number, so Microsoft decided we're going to hard code an estimate of 30% and just hope that that's good enough. We need to do something. Of course, this will not give you optimal performance in many cases, but it's all SQL Server can do. So SQL Server becomes a lot happier when it has a good idea of what the cutoff date is. If for whatever reason the cutoff date is known, then the optimizer can come up with a great estimate based on that cutoff date. If I pass in January 1st, 2026, the optimizer can look at the statistics of the table and say, oh, this table has data going back all the way from 2010 to today. You're only asking for the last 2 weeks. That will be just 1% of the data, so this number of rows. And if I put in a date somewhere in 2012, it will give me an estimate based on perhaps 90% of the data. So then, with that better estimate, you get a better execution plan. Whenever this code is in a store procedure, function, trigger, or anything else that has parameters, trigger shouldn't have said that because the trigger doesn't have parameters, then SQL Server can sniff the parameters so that even though the code says add cutoff date, it's a parameter, and SQL Server can look at the parameter passed in, sniff it, and say, oh, you're passing in this value, so now I'm going to give you an execution plan optimized for that value. So I hope that this convinces you that, yeah, parameter sniffing is a good thing. It can give you better execution plans. There's also another feature in SQL Server that we're all very happy that exists, and that is plan caching. Plan caching is because compilation of a query is expensive. The query I just showed was of course very simple, but even optimizing that query takes effort. We need to do estimates, we need to look at the metadata of the table. If you look at more realistic queries, the optimizer has so much work to do. Compilation is extremely expensive. And in a typical production machine, in a typical production workload, you often see the same query repeated millions of times per day. if you compile that query a million of times per day, that's a lot of overhead. And frankly, every time you compile it, it will be the same execution plan because you're asking the same question. So what SQL Server does, it stores the execution plan in the plan cache, also called the procedure cache. And then when the same query is executed again, SQL Server will simply go to the plan cache, grab the execution plan and reuse it, thereby saving that overhead of having to compile it again. And again, this is a good feature. Of course, there are cases where a new compilation is needed, so there's a lot of rules for when a plan is evicted from the cache, forcing a recompile when the query is executed again. Those are beyond the scope of this session. Just know that there are such rules. So when something changes that requires a new optimization, or when there has been memory pressure or other reasons, you will get a new compilation, and then that new compilation will once the execution plan is there, be stored in the plan cache again. Again, this is a good feature. So we have two good features, parameter sniffing and plan caching. Sadly, there are some cases where they have a detrimental interaction with each other. And that is when you get bad parameter sniffing. So this happens when, well, let's walk through some examples. And basically there are three main cases where you can get bad parameter sniffing. The first is the type of query I just showed, something with an inequality, like for instance a report with a cutoff date, or anything else with a larger than or less than, or a range between, or anything else that gives you a range. All those cases, if the predicate has a varying selectivity, then you can get bad examples. So let's give an example of that sales report with a cutoff date. Let's say that at the start of the day, a sales representative is the first who runs this query, and he wants to know all the sales for the week to date, so since last Monday. They enter that date. The execution plan is compiled and stored in a plan cache with parameter sniffing, because we want an execution plan that's optimal for the past in date. And that's then stored in the plan cache. Then the CEO wants to see all sales since 2015. SQL Server finds the plan in the plan cache and reuses it, but it was based on the sniffed value of last week. So now we run an execution plan that's optimized for just 1% of all our sales to get a report on 80% of all our sales. And that might give you terrible performance. So that is an example of bad parameter sniffing. Now, like I said, there are three main cases. This is one of them, the inequality predicate. This is a case that so far Microsoft has not tried to tackle. Perhaps they have plans, I don't know. But so far, this is all up to you to tackle. However, there is a second case where Microsoft has done work in 2022 already. And that is when there is an equality predicate on a column with a skewed data distribution. And I'm going to show this case in a demo. Where is my mouse? My mouse isn't working anymore. Oh, it is moving. I don't see it. So cool, I don't see it on my screen. See if it's back. I don't have a mouse pointer on my screen anymore. This is so fun. I love it when my computer does weird things.
Over you, the upper right corner.
Yeah, now I need to. There we go. Sorry, I don't know why my computer is giving me a hard time. Anyway, I'm first going to switch off and set some options to pretend we are before SQL Server 2022. So this is basically SQL Server 2019 compatibility mode. And I'm going to use this alter database scope configuration clear procedure cache to get everything from the procedure cache. This is not recommended for production workloads. I'm always going to say that, but this basically pretends something has happened to clear the procedure cache for at least this execution plan and this query. And I'm using a demo table I created in the setup script where, and it's a bit predictable, when I search for the value 100K, there will be 100,000 rows. If I search for the value 1, hey, there's exactly one row with that value. I deliberately set it up that way to make it easy for us to understand what's going on. So when I run this batch and look at the execution plans, what you will see is that the first execution plan uses a clustered index scan. Now, why do we have a clustered index scan? That is because SQL Server saw, hey, there's a parameter at B, and I'm going to sniff it, and the compile time value, you don't see the full text here, but the CO is short for compile time value, was 100K. Based on that sniffed value, we look at the estimates, and there's 100,000 rows estimated. So based on that estimate of 100,000 rows, SQL Server decided a clustered index scan is the best execution plan here. The second execution with the value 1 then reuse that execution plan. So we've got the same execution plan, but now you already see the estimate is far off. And that is because, once more, if I go to the parameter list, the compile time value is still 100K because we didn't do a new compile. We reused it. But at this point, we ran with the value 1. Now, is this bad? No, it's not that bad in this case. What you see is that every single execution took 853 logical reads, and that is good enough, hopefully. It might not be optimal, but it's good enough. However, we were lucky that the first execution used this 100K. The order could have been different. And if I reorder the statements and then execute the same batch again, now the first execution is for the value 1, which of course matches just one row. So now you get a different execution plan. In this execution plan, you see that now, because I removed the plan from the procedure cache, we got a new compile, and that new compile was based on the value 1. And based on the estimate of just one row, we are using this plan with the nested loops and a key lookup. And again, the execution plan is reused for every next execution, even though later executions have a different runtime value of the parameter. They still use the same plan compiled for the value 1. And now you see that this actually is quite detrimental for the cost. Yeah, the first execution was perfect with just 8 logical reads, but the second used over 300,000 logical reads. And this is the kind of behavior that gave parameter sniffing its bad name, because now all of a sudden, at a seemingly random moment, because in reality you don't run a statement to clear the procedure cache, something happens, and that something might be memory pressure, completely uncontrollable. So it seems like a random moments, all of a sudden queries start to behave badly, become slow, and then at a later time, all of a sudden they are fast again. That is a typical example of bad parameter sniffing. Now there's many ways that many things that we can do to try to fix them. A very simple method that always has been available is to add an option recompile to the query. This comes at a cost, because now basically we disable the plan cache for this query. So if this query runs 1,000,000 times per day, we're compiling it 1,000,000 times per day. The upside is we never reuse an old plan that was compiled for a different value. So if I run this batch, you will see that the execution plan, when I do it for the value 1, has the execution plan that is optimal for that one, but the second execution plan uses the scan. Then for the value 100, we have the seek plus lookup again, and for 90K, we have the scan again. And if I look at the messages, we see that we always have the lowest possible number of logical reads. So this works, but we had 4 compilations. And if this were a production query with 1,000,000 executions per day, we have 1,000,000 compilations per day, which is a lot of overhead. That is not always affordable. So if this option is too expensive for you, then you will need to do other things. And one of my YouTube videos has a discussion where I go through a variation of things you can do. There is a link on the screen, and you can also find that link if you download the presentation materials, so you don't have to type all the letters and numbers that you now see on the screen. Anyway, this was always the case. But of course, Microsoft didn't really like that their users have to work around this interaction and face these problems. So in SQL Server 2022, they released Parameter Sensitive Plan Optimization, PSPO, a first attempt to address this specific issue. And I'm going to jump right back into the demo to show how this affected everything. So now I'm going to enable the PSPO feature and then run the same thing again. Are we still running? Yeah, we worked. So I'm going to run the same batch again, but now with PSPO enabled. And now what you will see is the first execution plan for 100K uses the clustered index scan. The second execution uses the seek plus key lookup for the 1. This is optimal. Now, this might look like these were 2 compiles, and frankly they were, but this will not give you 1,000,000 recompiles if you do it 1,000,000 times per day. It works in a different way. So let's see how it works. The first time this query was encountered by the optimizer, it sees that there is a predicate, b equals parameter, that is on a skewed column. It meets the criteria for being sufficiently skewed to qualify for this feature. And at that point, the optimizer doesn't create an execution plan. It first creates a dispatcher plan. And that dispatcher plan, you can see it here, and I will zoom in after clicking the expand buttons. That dispatcher plan tells us there is a predicate, and you can't see it completely, but the predicate here says basically b equals @b. For that predicate, we're going to use a specific statistic, this statistic, to estimate for the current value of b, and that's a runtime decision. Is this an estimate below 100, or is this an estimate up to 100,000, or an estimate over 100,000? Well, the estimate is exactly 100,000, and that is included in the above part. So at this point, the optimizer said, okay, we're going to create an execution plan for a high number of rows. And that execution plan is then called a variant. And you see here the query variant ID is 3, the highest number. Do we already have a plan for this variant? No. Now we're going to compile a plan and store that in the plan cache. So we have a dispatcher and an execution plan for variant 3. Then we run for 1. And we already find a dispatcher in the plan, in the cache. So this existing dispatcher is now checked again. And it says, okay, the estimate for the value 1 is 1. That's below 100. So now I need query variant 1. And you see here, indeed, query variant ID is 1. I don't have a plan for variant 1 yet, so let's compile it, let's put it in the cache. And this one is optimal for a low number of rows. So far, it all works well. The third execution is for the value 100. Now we look at the dispatcher. This is the middle range. It's 100 to 100,000. So we get query variant ID 2, and again, there is no plan yet in the cache. We sniff the cardinality, we compile the plan optimal for the value 100. And if you look at the parameter list, you will indeed see that this one is compiled for 100. And then the fourth execution for 90K, we look at the existing dispatcher. This is between 100 and 100,000. Oh, we already have a plan for variant ID 2, so now we don't get a compile. The plan cache kicks in, and we use the plan that was compiled for the value 100 while we're running with 90K. And this is exactly where the weakness of PSPO starts to show, because, and you also see that in the messages, the first 3 executions used an optimal number of logical reads, but the fourth still is pretty slow. That middle range is not well thought out. It's not, doesn't use the boundaries that it should use, where we actually have the cutoff point between the two plans. And that is a huge weakness of PSPO. Now, in this case, this is a simple example with just a single predicate. Your real queries usually have multiple filters, and more of them may be skewed. SQL Server will try to identify all the filters that are sufficiently skewed for this feature, and then up to 3 can be used in a dispatcher. So if there's more than 3, the optimizer will pick 3, the 3 it thinks are best. Here's an example where I have 2 skewed filters, and just to show how that looks, if I now look at the execution plan, there's still a dispatcher, but the dispatcher has 2 parameter sensitive predicates, 1 for B and 1 for C. And that means that we now have 3 times 3 is 9 possible plans, 9 variants, and this version is, for instance, variant 7. So the variants are now 1 through 9. You have 3 predicates, that will be 1 through 27, and that's where it ends. You will never have 4 predicates because only 3 parameter sensitive predicates will ever be used in the dispatcher. So that's how this type of bad parameter sniffing was tackled in SQL Server 2022. Back to bad parameter sniffing. I told you there's 3 categories. I discussed 2. The third, and now we're finally getting to SQL Server 2025, is optional parameters. All those procedures you have where the users have 20 fields on their screen that they can fill out, and then whatever they fill in will be sorted on and the rest will be ignored. A very common business case, but also prone to bad parameter sniffing. And again, let me first demonstrate the problem. So here I have an example with a find order store procedure, and you see a whole list of parameters that are all optional, and in the code you will see typical construction like either you passed in null for the salesperson ID, then everything matches, or you did pass in something and then the salesperson ID in the sales order header table has to match what you passed in. And we do that same thing for all the other parameters. So let's make sure we create this store procedure. And I am now in SQL Server 2022 compatibility effectively. So optional parameter plan optimization does not kick in yet. And the first user after the plan has been evicted from the cache searches for a sales order ID. After that, someone searches for a special offer ID and so on. You see the examples on your screen. If I execute this, you will see in the statistics IO that the first execution was fairly good. All the numbers of logical reads are all low numbers. 60 is the highest number. We were done in, that's a bad pointing. We were done in 75 milliseconds. Cool. But then we searched for special offer ID 5. And now we see that this took 0.6 seconds, and we have many high numbers in the logical reads. This is a very expensive query execution. Why is that? Again, here the interaction backfired. So the first execution plan looked at all the parameters, and you see that there's a lot of parameters here. And let's expand a few. What you see is that for a sales order ID, the compile time value was 50,270. For special offer ID, the compile time value was null. So we got an execution plan that was optimal for these values. Parameter sniffing doing what it's good at, and we are happy. This execution plan is stuffed in the procedure cache, and then the next execution reuses that cached execution plan, which means that now we have an execution that was still optimized for sales order ID 50,270, special offer ID null. But we're running with sales order ID null and special offer ID 5. We get correct results. The execution plan still gives us what we want, but we don't get it fast. This plan was not optimized for these values. Of course, again, option recompile could come to the rescue if we can afford all those recompile costs. But we rather don't. And here again, which version is optimal changes. Now, after this was the first call, these two calls were slow. The last call I didn't show it, but that was fast, kind of by accident. But that's the weirdness you will have. But what if the first execution had been special offer ID and the second had been on sales order ID? Then, if you look at the IOs and stuff like that, you will see that the first execution, well, this is the most expensive table, 1248 logical reads, and we were done in 66 milliseconds. Searching for a special offer ID can be very fast, but now we have an execution plan that is not really fast when we search for a sales order ID. 360,000 logical reads here, 390 milliseconds. So again, whenever the plan is evicted, a new plan comes into the cache and other execution will be slow. And this is also the case with that erratic query performance that's so typical of bad parameter sniffing. So in SQL Server in 2025, or rather in the years leading up to 2025, Microsoft said, we have this architecture that we created for parameter sensitive plan optimization, this what they call multi-plan architecture. Let's use this structure to now also implement optional parameter plan optimization, short OPO. We use the same basic idea, but now not for skewed distributions, but for parameters that are clearly optional. How am I doing for time, Ben?
Half an hour.
Half an hour, thank you. Then I'm indeed doing good. So let's move to compatibility level 170, set parameter, optional parameter plan optimization on and rerun the previous demo. So these are the exact same calls I used before. If I now run them, you will see that the first execution, once more, I should scroll a bit further, all those low numbers of logical reads, it's awesome, only 57 milliseconds, great. Second execution now also is good, because now, hey, there we also have low numbers of logical reads and only 180 milliseconds. The third execution, cool, well, no, it's not all cool, because this third execution still is slow and uses a lot of stuff. So we already see that while things are better, they are not good yet. There's still a problem here. How does this work? Again, the same multi-plan infrastructure is used. So the first time SQL Server executes this stop procedure, it says, oh, we have parameters. There's no skew. That's not our problem. But we see that there are optional parameters. I'm going to use that same dispatcher. So once more, we first create a dispatcher plan. And in this dispatcher plan, there is one optional parameter, a predicate. Sales order ID is null. There's no ranges here. It's simply it's null or it's not null. So the first execution, when we passed in sales order ID equals 50,270, the optimizer said, I'm going to create a dispatcher where I look at whether the sales order ID is null or not. And then, because in this case it's not null, I'm going to create query variant 1. I'm going to compile an execution plan. For that execution plan, I'm going to sniff all the parameters. You will see them all here. And I'm going to create an execution plan that is optimized for 50,270. And it will be optimized for all the rest being null, because that's what we passed in. Then on the second execution with special offer ID equals 5, SQL Server looks at the existing dispatcher and says, oh, I have a dispatcher. I need to look at sales order ID. Sales order ID is null in this case, so that's query variant ID 2. I'm going to compile an execution plan based on sniffing the parameters, and this execution plan will be based on, it helps if I click on the plus instead of just next to it. This execution plan will be based on sales order ID is null, special offer ID is 5, and the rest will all be null. I didn't expand it, but you can trust me. And now we go to the weakness, because the third execution plan looks at the existing dispatcher. The dispatcher says, you need to check whether the sales order ID is null or not. Sales order ID is null for this third execution. So now we reuse the plan for query variant ID 2, as you see here. That plan was in cache now, so this is not a new compilation, that's the upside. But the downside is this plan was now obviously compiled for special offer ID 5, product ID null. But in reality, it's now executed with special offer ID null and product ID 863. So this plan is once more not optimal for this use case. So we see it does something, it helps a bit, but not really good enough. There's also a weird predictability issue here, because if something causes this to go out of the cache and the order is different, now once more SQL Server will do this execution for product ID equals 863. There's now nothing in the plan cache. SQL Server once more realizes, oh, there's optional predicates here. And in this case, it says, oh, you call it with product ID 863. Now I'm going to create 3 optional parameter predicates. And they are for customer last name, order month, and sales order ID. Why these 3? Frankly, I don't know. I have not found any documentation to tell me how SQL Server chooses the optional parameter predicates to recognize in the dispatcher. The store procedure has 6 optional parameters. The dispatcher has a maximum of 3 predicates, so it can't use all 6, but it picks 3 seemingly random here, but it always picks these 3 if my first call is with a product ID. My first call is with the sales order ID, then it always picks just 1 with the sales order ID. Then you can play with other orders, you will get other choices in those cases. So this is weird. There's another problem with optional parameter plan optimization, and that is this whole multi-plan infrastructure, like I said, has a maximum of 3 predicates. But where before we had 3 predicates available to parameter-sensitive plan optimization, now we have 3 predicates available to parameter-sensitive plan optimization plus optional parameter plan optimization, which means they're competing. So here I have an example where I use 2 optional predicates on skewed columns. I'm back to the sample database that I used in the first demo with PSPO. So we still have skewed data, but now they're optional predicates. And now SQL Server has to make a choice. It sees 2 skewed columns. It sees 2 optional predicates. It has a maximum of 3. So it has to make a choice. And what is the choice in this case? Let's look at the dispatcher. I see 2 parameter-sensitive predicates and 1 optional predicate. And that means that the optional predicate C is null, is not recognized here, which can lead to bad performance in some cases. And once more, we have a predictability issue, because if I just flip the order of these 2 after the plan has been evicted from cache, SQL Server once more has to make a choice. But now the choice is, oh, let's do 2 optional and 1 parameter sensitive for B. You can see that now, and when I zoom in, it's gone. But now the parameter sensitivity of C is no longer recognized. And this is once more unpredictable. Which 3 will be chosen apparently depends on what is executed first. So PSPO and Oppo use the same multi-plan infrastructure with up to 3 dispatcher expressions, which can be either a parameter-sensitive predicate, and it says on the screen up to 100 to 100,000 or above 100,000. These values are actually based on the lowest and highest value in the statistic distribution. So in different demos, you can have different low and high bounds. But they always have this very large medium range, where in my experience, you will still have bad parameter sniffing biting you in the back. as the special expression. It can also be an optional parameter predicate with add parameter is null. So you get the maximum is still 27 plans. If you have 3 parameter sensitive predicates, if you have 3 optionals, it will be at most 8 plans, and then there's all the kinds of variations. There's a lot of limitations. I touched on a few of them in the demos. So those boundaries for the low, medium, and high thresholds in parameter sensitive plan optimization, they are not based on the actual thresholds in the execution plans. And part of me says they should be, and in the simple examples that I showed, it would not be hard to have the optimizer work out, oh, the place where I will switch from the plan with a seek and a lookup to the plan with a scan. That would be around, let's say, I'm just making up numbers now, but the optimizer can compute that cutoff point would be at 1265 rows. Why then not have one range below 1265 and one range above 1265? Of course, in real queries where there's multiple other predicates, it's not that simple and not that clean cut. I still think that Microsoft could have done a better job of this. But that's not the case. They're simply based on the statistics for that column without taking anything in the query in consideration. And the medium range is so wide that there is still bad parameter sniffing going on here. You do get much better performance for everything in the low and the high range. It's not a bad feature. It's just, in my opinion, not good enough. 3 dispatcher expressions for purely parameter sensitive plan optimization, I was fine with that. For optional parameter plan optimization, those store procedures that need it always have more than 3 parameters. There's very few that have only 3 optional parameters. Most of them have way more. So the choice to limit this to 3 is, in my opinion, a bad choice, making optional parameter plan optimization really suboptimal. And sharing those 3 with parameter sensitive plan optimization even means that you have a risk of a regression if you upgrade from 2022 to 2025, because right now you might have queries with 3 skewed things and something optional, and you in SQL Server 2022 you will get different plans for those 3 skewed columns. In SQL Server 2025 you run the risk that optional parameter picks one of those predicates and you only have 2 left for the skewed stuff. So that is a risk. And simply, like I said, for PSPO alone, I was fine with 3. For Oppo alone, 3 is not enough. For Oppo plus PSPO, it's definitely not enough. And like I saw in the demo, when the optimizer has to choose which dispatcher expressions to use, you can get different combinations. You will always, for every query, only have a single dispatcher plan in the plan cache. But if after some time you look in the query store, you might find that the same query has in the query store like 6 different dispatcher expressions. So now we get a new case of bad parameter sniffing where the same plan sometimes works good in all cases that are regularly used, and then in another case, you get different dispatcher expressions, and now it suddenly works bad. A new challenge for us to troubleshoot this. So these are some limitations. And then I also found that the logic to recognize when we have an optional parameter is also not as good as I would like it to be. So let's look at some examples. So far, I used the format that was shown in the documentation. Add parameter is null or column is add parameter. What if I reverse that? Column is parameter or parameter is null. It's just the same, just a different order. Will SQL Server recognize that? Well, let's look at the execution plans. There is a dispatcher. You have an optional and a parameter sensitive. It's the same basic example as before. So this limitation of 3 still hurts us, but the optional parameter sensitive predicates are recognized even if I reverse the expressions. That's good. Point for Microsoft. I see a lot of code at my clients that don't use either of these expressions. They use something like column equals coalesce parameter column. If the parameter is null, this coalesce will simply return the column, and the column is always equal to itself. If the parameter is a value, for instance 12, then this will return 12, and we search for b equals 12. It's simply a shorter way to write the same thing. Many developers like short, so this code is used often. I would expect SQL Server to recognize this form as well. But when I look in the execution plan, there is no dispatcher here. This is an alphabetic list. There is no dispatcher. So not only did SQL Server not recognize that these are optional predicates, SQL Server also didn't recognize that we're searching on a skewed column. All those benefits are gone because someone saved some keystrokes. Now, thank you. Now, coalesce is, I prefer coalesce over is null, but many people use is null instead. Coalesce is standard, coalesce supports multiple parameters, is null is SQL Server only and only supports 2, but it also has some unique behaviors that coalesce does not support, and that sometimes make it the better choice. So even though I prefer coalesce, sometimes I have to use is null. And this is also a form that I see at a lot of clients because many people prefer using is null over coalesce. Perhaps Microsoft did a better job here. Well, let's look. No better job, no dispatcher expression. So again, optionality is not recognized, the skewness is not recognized. Here, I think in both these cases, Microsoft really dropped the ball. Now, there's also the reverse case. What I didn't show you yet, in reality, the columns B and C in the PSPO table are nullable. So if I want to search for the value null by passing it in, I can't just use b equals add b because null is not equal to null. Then I have to use a construction like this: add b is null and b is null, searching for the null value or searching for a non-null value. This is not optionality. This is how you have to code around how SQL Server handles null values. Would SQL Server accidentally think this is optionality? I hope not. There is a dispatcher and there's only parameter sensitive. So this is once more a point for Microsoft. They handled this case very well. Frankly, if you are on SQL Server 2022 or above, you should not write your code this way, because in SQL Server 2022 is not distinct from, was introduced as a new syntax to help you with proper null handling for searching on nullable columns. And if I use this, I get the exact same execution plans and the exact same benefit of dispatcher recognizing parameter sensitivity, but not thinking this is optionality. Okay, but now that I know that I might be want to search for the value null, what if I do want to have optionality? Now I can't use add b as null to consider this as an optional parameter, so I have to use a different magic value. And on a numeric column, it might be -1. On the date column, it might be January 1st, 1900 or something. And here I use a value in the column that I know does not exist in my data, the value I don't exist. This is basically an optional parameter. It just doesn't use null as the magic value. It uses a different value. Will the SQL Server recognize this as, oh, there's an optional predicate here? Not really surprising to me. I didn't expect it. And indeed, parameter sensitivity is still recognized, but this is not recognized as an optional predicate. This one I can forgive Microsoft for not supporting coalesce and is null as ways to handle optional parameters is, in my opinion, a bad mistake. So that is parameter sensitivity, parameter sensitive plan optimization and optional parameter plan optimization. I still have about 10 minutes left, so I'm going to very quickly run you through a few things about optimized logging. And to understand that, I first have to talk about the version store. The version store was introduced in 2005 already, and to support snapshot isolation and read committed snapshot isolation. What the version store does is whenever data changes, so for person 60, I'm going to update the country from Denmark to Greece. Jimmy Brown has moved. Instead of just changing the data, an old version of the row is first stored, and then the new version is updated. To keep these connected, some extra data is added, so the row grows by 14 bytes to have a pointer to those older versions. Those older versions are stored in TempDB, and of course there is a cleanup process for when versions are no longer needed. That is the version store at a very high level. In SQL Server 2019, Microsoft introduced the persistent version store. That was needed to support accelerated database recovery. Persistent version store is effectively just the version store, except now, okay, there's some small differences, basically the same, except that now we don't store it in TempDB anymore, we store it in the user database, which helps us to persist the version store on restart, which was needed to support accelerated database recovery. This feature was used to do optimized Halloween protection. I'm going to skip these slides because we're not going to talk about optimized Halloween protection. But this feature was also used, why do I have so many slides? Yeah, to talk about, to implement optimized logging. And to understand optimized logging, let's first talk about classic logging. When you do modifications to a row, SQL Server needs to log it to prevent concurrent updates. These are done on a per row basis, and when they're no longer needed, they are released. That means that sometimes if you do a lot of updates to a table, you might have a lot of logs that are needed until the transaction ends. And that is overhead. If you have thousands of logs, all of them use memory, all of them use resources. Of course, there is a threshold where SQL Server will say, oh, you now so many logs on the table, I'm going to escalate this. You can set the threshold, the behavior is there, and then it will just lock the table. That saves a lot of resources, but now you lose your concurrency because the entire table is locked. So that is a problem. Optimized logging tries to prevent that by using transaction ID logging, which requires this accelerated database, or rather it requires the persistent version store, but you only get the persistent version store when you enable accelerated database recovery. So you need to enable accelerated database recovery, and then you can also choose to enable optimized logging. I'm going to skip the demo in order to save some time. What you would see in the demo is first, without this option, I do an update to a table, and then you can see that there's hundreds, thousands of logs on that table. In a concurrent transaction, I can still access non-locked rows and not accessed locked rows. If I would escalate to table locking, you would not be able to access anything anymore. Then I enable this feature, and now we get only a single log at the transaction ID. And when a concurrent transaction tries to access that row, it looks at, oh, the transaction logs this. Let's look in the version store for that transaction whether this row is locked. This works only for exclusive logs, and it only works in read committed isolation level. If you use repeatable read or serializable, it doesn't work. That's also in the demo. Then there is a second part of optimized logging, which is log after qualification. That solves a different problem with logging, but it also uses this persistent version store, this accelerated database recovery. So you also need to set optimized logging on. However, log after qualification also requires that you enable read committed snapshot isolation. So there's a lot of requirements. But if you have them all, then you get this feature. And this is the demo I'm going to show. I hope I have enough time to finish it. So let's make sure we have everything enabled that we need to enable. And first, let's see this without log after qualification. So I have an orders table, I have some orders in there, and what I'm going to do is I'm going to update all the orders for product ID 1. You see that I begin a transaction, I don't commit or roll back the transaction yet. So now those rows are in modification, the logs are there, and you will see that there are some logs here. Not many, I just updated the 2 rows because there are only 3 rows in the demo table, but those rows are exclusively logged, nobody else can access them. Now I go to a different window, so I'm going to copy and paste this. And here, what I want to do is update the orders table for product ID 2. Those are different rows. There is no overlap. The running transaction only affects product ID 1. So you would expect and hope that this can just finish, but it doesn't. It sits, it waits, it can't complete. If I now look at the log statement, and that was 56, I need to put in the correct session ID here. If I now look at that session, I will see that it is waiting for a log. It wants an U log. That means I need to read this, and I might want to upgrade to an update log later, but first let me read it. And SQL Server says, I'm not going to let you read it because it's exclusively logged. Why is this? Well, to understand that, we have to look at the execution plan. So I cancel this. I'm going to try the update again, but now only look at the execution plan. And what you see is SQL Server doesn't have an index to only access product ID 2. So we scan the index and we filter on product ID equals 2 here. In this scan, we also encounter the rows with product ID 1. We don't need them, but we only know that after we read them, and we're not allowed to read them. And that is why this doesn't complete. Let's roll back this transaction. Let's roll back this transaction. And let's now switch to log after qualification. So I'm going to enable the features that I need here. And then I'm going to run the same demo. So I'm going to run this update. And because I now have optimized logging on, log after qualification always comes with optimized logging, I now have transaction logging, so the log is on the exact. You would have seen this before if I had executed the demo that we skipped. Let's now try the conflicting update. New window. If I run this and I'm going to enable the execution plan, it should finish, and there's something wrong with my demo and I don't understand what. Let's see if I can realize what I did. I realized what I did wrong. I only enabled optimized logging, but not yet log after qualification, because I forgot I did not run this part that also enables read committed snapshot, which was one of the requirements. So let's first roll back the transaction. Let's now execute this as well. And now we should get log after qualification. So once more, do an update. Stuff is logged, but with transaction logging. A non-conflicting update that previously was logged, and now it just completes. Did we get a new execution plan? No, we still scanned the entire index. We still had to skip past the product ID 1, but we were no longer blocked. Why is that? That is because SQL Server now uses read committed snapshot isolation to say, okay, in this scan, I'm searching for what I need to update. Let's take an optimistic log using read committed snapshot isolation. I know that the row is locked. I just use snapshot isolation to get the last good version. That is product ID 1. I don't care about this row. Let's go to the next row. Oh, this isn't locked. I can just read it and I can update it. And then the next row once more. So every row is read. If it doesn't qualify, we don't care that it's locked because we're going to skip it anyway. If it does qualify, then That point we try to upgrade, and there is another demo, but I don't think I have time for that anymore, where you can see that if you make the conflicting update affect the same product ID, then you will indeed get a log. But now it's after reading the row optimistically, say, oh, we need to update this row. Oh, damn, it's locked. And then we still have to wait. This is still not making you unsafe. It's just a different way. You can get different problems here because every time you use snapshot isolation, you get other problems if there are update conflicts. But all those cases where you were waiting to find rows to update and something you didn't need blocked you should be gone with this feature. So that is how log after qualification works. I already ran this demo. I normally explain it first and then show it, and I decided to do it in a different way. Ben, were there any questions?
There were not.
There were not. So either I was entirely clear or everyone has drifted off to sleep. You can wake up now. The next session will be interesting again. I don't know who is, but I'm sure they will be more interesting. If you do have questions later, please mail me or hit me up on Blue Sky. I will be happy to address you. If you send me an email and I don't respond, don't take it personal. Sometimes there's so much mail that I see your mail. I think I will get back to that tomorrow. And then the next day there's 20 Viagra ads in my inbox. And I overlook your mail because they are, of course, way more interesting. So if you don't get a reply within a week or so, just send me a reminder. I'm okay with that. I try to answer every relevant question. That's it. I'm done. I think, how much time do I have left, Ben?
-2 minutes.
Oh, I'm still over time. I didn't break your ideas about me. Well, thank you.
Great tradition to have.
Thank you all for your attention. I hope you enjoyed this, and I hope you will enjoy the rest of the day. There's a lot more sessions planned. In my surprise that I didn't need to thank Redgate because Ben already did, I forgot that I also had plans to thank Ben and William for all the hard work they have done and do to make this event possible. So even though they won't hear it, do a round of applause for Ben and William.